Alright, so this is video review for lines through digit 6-4. After you're done with this, you'll be getting a worksheet that's going to be due tomorrow at the end of class. If at any point during this video you want to try one of these on your own to kind of test yourself, then please pause and try it on your own. Otherwise, I'll be going through all of them. So let's start with number 1. Graph the following sets of ordered pairs, then find the slope of each. Count using rise over run. So number 1, we're going to plot in purple. So we plot -3, -3. We go over -3. We go down 3. We put our first point. We then plot 6, 3. We go over 6, up 3. And it says count using rise over run. So we're going to rise up, and then we're going to run over. Since we're going to the right, we know this is going to be a positive slope. So we go up 1, 2, 3, 4, 5, 6. So rise is 6 over the run. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 over 9. So we want to make sure that that can't be reduced, and it can. So 6 over 9 is equal to 2 over 3. That's our final answer. Again, at any point, if you want to pause and do the other one, see if you get it right, that'd be great. So number 2, I'm going to do in green. We're going to go -4, up 3, so over -4 and then up 3. So over -4, up 1, 2, 3. And this one is 1, -7, so we go over 1 and down 7. And then we count using rise over run. So we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our rise is 10. And since from here we're going to the left, we know that this is a negative slope. So we go over 1, 2, 3, 4, 5. So -10 over 5, and that's equal to -2. So that would be our slope for the second one. Alright, for numbers 3 and 4, we're going to use these lines down here and write the equation of each line in slope-intercept form, which is y equals mx plus b. So I zoomed out a little bit. So number 3 is this blue line here. So we look at the blue line. What is our rise over run? What's our m? Remember, m is slope, which would make b our y-intercept. So let's start right here at this point. We're going to rise, and we're going to go to this point. On your worksheet, it shows up better on my computer. So up 1, 2, 3. So our rise is 3 over 1, 2. Run 2. It is positive because we went to the right. Our b is also 2 because it's where it crosses the y-axis. It's where this line intersects the y-axis. So our slope-intercept form is y equals 3 over 2x plus, and then we'd put our b, which is 2. Alright, let's do number 4 in green. This time I'm going to pick this point here and this point here. So I rise up 1, 2, 3, 4, 5. So my rise is 5. And I'm going to run over 3. And since I'm going to the left, I know my graph is negative. And my b, again, is my y-intercept. So if I look down here, I can see it crosses at -3. So my y equals mx plus b, or slope-intercept form, will be -5 over 3x minus 3. So that is slope-intercept form. Alright, for 5 and 6, we're solving for y in each equation, and then we're graphing using slope-intercept form, and we're stating the solution to the system of equations. So right here, we're going to be putting an ordered pair. So I'm going to show some of my work over in the margin off to the side. Again, if at any point you want to pause and see if you can do this by yourself, go for it. I'm going to rewrite the first equation because if I look here, my first equation is not in y equals mx plus b form. My second equation is, so my second equation can stay, but my first equation needs to be changed to y equals mx plus b form. So basically I'm trying to get y alone because remember, we heart y equals mx plus b. Whoa, that looks a little bit funky. So we want it, our y all by itself. So we minus x from both sides, and we get y equals negative x plus 1. So I'm going to graph those two lines. This graph I'm going to graph in purple, and this graph I'm going to graph in red. Let's do this red one first. I first graph my y-intercept, which is plus 1. And now my slope, remember there's a 1 implied right here, so I go negative 1. Up 1 to the left 1, up 1 to the left 1, up 1 to the left 1, and so on and so on and so on until I run out of room. I cannot go any farther. Okay, now my purple one, and I'll add the lines later. My purple one, my y-intercept is 6, so I go up to 6, and my slope is 3 over 2x. It's positive. Well, if I went up 3 and over 2, I'm running out of room. So now I'm going to go down 3 and to the right 2. Down 3 and to the right 2, or the left. Down 3 and to the left 2. Okay, so now that I've graphed them, what we look at is where these two lines cross, which is right here at negative 2 for my x, comma 3 for my y. So that is the solution to this system, where they cross. All right, let's try number 6. And again, if you feel like you want to try this on your own, please pause here. Remember, we want it in y equals mx plus b, all of them. So I'm going to do this first one here. Actually, let's do it in red. Do the first one in red. We have y minus 2x equals 1. Is this in y equals mx plus b? No, it's not. So I need to add 2x to both sides. This is y equals 2x plus 1. So there's my first equation. Let's do my second one in blue. Second one, I'm going to copy it back over here. 3x plus 2y equals negative 12. Is this in y equals mx plus b? No, it's not. How do we get this y alone? Well, first thing we want to do is minus 3x from both sides. And we get 2y equals negative 3x minus 12, because this is negative. Now this y still isn't alone, so we have to divide by 2. When we divide this by 2, we have to divide this by 2 and divide that by 2. So we get y equals negative 3 over 2x minus 6. So we have our two equations, this one right here and this one right here. Let's graph our red one first. We go up to positive 1 and we put our y-intercept. We get that from right here. Now our slope is 2 over 1, so we go up 2 over 1, up 2 over 1, up 2 over 1. We've run out of room, so now we go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Now for our blue line. Our y-intercept is negative 6, so we go down to negative 6. And our slope is negative 3 over 2. So we go up 3 and to the left 2, up 3 and to the left 2, up 3 and to the left 2. Alright, and as you can see here, my lines cross right down here. And this coordinate, remember we're writing it on this line in parentheses, is negative 2 comma negative 3. Negative 2, negative 3. Alright, let's move on to number 7. So flip your page over. Number 7, which ordered pair is a solution to the system of equations? And make sure you show your work. So I'm going to do this over here in this area. So really the only trick to this is plugging in or substituting in negative 3 for x and 2 for y and seeing if the equation is true. So for the first one we have negative 3 plus 2. Does that equal 3? Well, that's negative 1. Does not equal 3. So we already know that this one is not a solution. Let's try B. We have 0 plus 3. Does that equal 3? Yes, 0. Oops. Plus 3 equals 3. Yes, 3 equals 3. So that's good for this one, for this first one. Now let's try for this second one here. So 7 times 0 minus, and then we put in our y, 3. Does that equal negative 3? Well, 7 times 0 is 0. 0 minus 3 does equal negative 3, so that's good. This is our solution. Okay, number 8. Decide whether each system of equations has no solution, one solution, or infinitely many solutions. Hint, solve for y in each. So in this case, y is already solved for in your first one. So let's solve for y in the second one right here. And all that means is get y alone. So in order to get y alone, we want to divide it by 2. So we divide this by 2, and we divide this by 2. So what that leaves us with is negative 3x plus 4 equals y, which is the exact same thing as this first equation. So what this tells us is when we have the exact same line, y equals negative 3x plus 4, and y equals negative 3x plus 4, is that there will be infinitely many solutions. So remember, infinitely many. Alright, letter B. Again, our hint is to solve for y, so let's do that. Y plus 7x equals 0. Well, for this one, I'm going to minus 7x from both sides. So I'm going to put that one. Y equals negative 7x. I'll do the next one in green. This one I'm going to minus x from both sides. So I get negative y equals negative x plus 13. Well, I can't have a negative y, so I divide this by negative 1. If I divide this by negative 1, I have to divide this by negative 1, and I have to divide that by negative 1. So my final equation being y equals x minus 13, basically just changing all the signs. So now we're comparing this equation here with this equation here. Well, how do we know if it has one solution, no solution, or infinitely many? Well, this one up here had infinitely many because it was the same exact equation. This one here we know has one solution, y, because it has different slopes and different y-intercepts. Up here it had the same slope of negative 3, same y-intercept of 4. This one here has a slope of negative 7 and a slope of 1. This one has no y-intercept, or 0 as their y-intercept. This one has one of negative 13. So we know this one has one solution. Now C. Does C have one, none, or infinitely many? Let's try it. Again, we're trying to get y all by itself. So I'm going to rewrite this first one over here. 8x plus 2y equals 6. First thing I want to do is subtract 8x from both sides. We get 2y equals negative 8x plus 6. Now again, we want to divide by 2, which means we divide this by 2 and divide this by 2. So y equals negative 4x plus 3. 8 divided by 2 is 4, 6 divided by 2 is 3. So there's one of them. Now again, at any point, like right now, if you want to just pause while I solve this one and then fast forward to see my answer, that might be good for you to get practice. So how do we get y alone here? Plus 20x to both sides. This cancels. We get negative 5y equals 20x plus 15. Again, we're going to divide by negative 5. So this becomes 1. This is all alone, that y. Y equals negative 4x minus 3. Now let's compare these two equations. They have something in common, and what's in common is the slope. This slope is negative 4, and this slope is negative 4. So because they have the same slope, we know they have no solution. Same slope, different y-intercept. This one's positive 3, this one's negative 3. These lines are parallel. They would run parallel to each other. Okay, so number 9, we're using a bunch of substitution. And here, I'm going to do the first one, and I am going to have you pause for B and C to see if you can solve those out all on your own. So, number 1, y equals 2x. So we know we put 2x in for this y right here. We're substituting it in. We get 6x plus 7, and instead of y, we're writing 2x equals 20. And now we're going to solve for x. We've seen this a ton of times. 6x plus 7 times 2x is 14x equals 20. 6x plus 14x is 20x equals 20. Divide both sides by 20. X equals 1. So we're not done. We just put our 1 in the x position. Now we need to get y. We substitute x in, or 1 in for x up here, and we get y equals 2 times 1. So y equals 2. Alright, so now pause here. I'm going to show all the work for B and C, but I want you to first try it on your own. A little hint. First, you're going to solve for y in this one. And in this one down here, you're going to solve for x. So up here, you're solving for y. Up here, you're solving for x. Okay, so for B, you should have solved for y first right here and gotten negative 3x plus 5. Now this here, green, goes in right here for this y, because y equals negative 3x plus 5. So I show that over here. That 5x minus 4, and instead of y, you're going to write negative 3x plus 5 equals negative 3, and you solve that for x. Once you get x equals 1, up here, you substitute 1 in for x down here, which is just y equals negative 3 times 1 plus 5, and you get your y being 2. So this, if we were to graph these two lines, that is where these two lines right here would cross. So for C, you do basically the same thing, only this time your x is isolated. So first is right here. We subtract 3y from both sides. So x equals negative 3y plus 1. Now that goes in for, is substituted in for x right here. So instead of negative 3 times x, we have negative 3 times negative 3y plus 1 minus 3y equals 15. And that's coming from this equation right here. We solve for y, we get y equals negative 2. Then we substitute y equals negative 2 back in to this here original equation to find x. And we get x equals 7. So our ordered pair in this case is 7, negative 2. That is where these two graphs cross. Once you're done, please pick up a homework sheet. If you don't get anything, please go back and re-watch it. Hope it helps.